The Severn Estuary is home to the second largest tidal range in the world, a force clearly visible from space.
A massive multi-kilometer coastal lagoon harnesses the natural rhythm of ocean tides. Advanced bathymetric surveys map seabed soil composition and tidal velocity vectors. Geotechnical core drilling verifies stable limestone bedrock foundations beneath coastal mud. Heavy maritime logistics fleets mobilize millions of tons of quarry aggregate. Industrial geotextile membranes are laid across the seabed to prevent core scouring. Heavy marine cranes position core quarry rock to anchor the breakwater perimeter. Split hopper barges deposit heavy stone mounds with satellite positioning accuracy. Rising from coastal waters, the multi-kilometer breakwater structure breaches the sea surface. Interlocking concrete armor units are hoisted into place along outer breakwater slopes. Acoustic positioning systems lock every concrete armor block into a rigid protective matrix. Continuous reinforced concrete wave walls crown the exterior breakwater ridge. Massive concrete caisson structures are fabricated inside specialized coastal dry docks. 30,000-ton concrete turbine caissons are towed out to final lagoon positions. Controlled ballasting sinks caisson modules precisely onto prepared seabed foundation trenches. Underbase high-pressure grouting seals every millimeter between caisson and bedrock. Massive bi-directional bulb turbines are installed directly into concrete caisson housings. Laser alignment micrometers ensure perfect rotational balance across heavy turbine assemblies. Colossal electrical generators convert rotational turbine energy into clean baseload power. On-site transformer galleries step up electrical power for transmission to the grid. Automated sluice gates control rapid water filling and emptying cycles across tides. Incoming high tide fills the lagoon basin, driving water through massive turbine blades. Outgoing low tide forces trapped basin water outward, generating power on the ebb. Spanning square kilometers of coastal water, the lagoon creates a reliable tidal reservoir. Piezometer sensor arrays verify internal breakwater stability under continuous tidal pressure. Fiber optic networks monitor real-time structural stress across all concrete caissons. Autonomous drone fleets inspect breakwater armor geometry for shifting block displacement. High-voltage submarine cables transmit generated clean energy directly to national power grids. Large-scale battery storage units smooth out tidal generation cycles for steady baseload power. Comprehensive ecological studies ensure marine wildlife thrives around breakwater structures. Acoustic deterrent systems protect marine fish populations safely away from turbine blades. Centralized digital control hubs optimize energy generation parameters across all turbine units. Integrated public walkways and cycle paths turn industrial energy assets into community spaces. Britain's mega tidal lagoon plant stands as a revolutionary milestone in marine renewables. Harnessing predictable ocean tides secures clean baseload electricity for future generations. Tidal lagoon energy transforms the power of the oceans into an endless clean fuel source. Expanding regional tidal networks requires continuous engineering innovation across coastal estuaries. Large-scale battery storage units smooth out tidal generation cycles for steady baseload power.
Modular air filtration units maintain pristine internal atmospheres within electrical galleries. Dual conduit isolation chambers separate high-voltage power lines from fiber optic telemetry networks. Continuous supply chains deliver high-performance concrete mixes to coastal construction zones. Rigid, non-destructive testing certifies structural resilience against extreme tidal stress cycles. Robust grid interconnectors transmit renewable tidal power reliably across regional networks. Hydraulic dampening arrays protect critical gate infrastructure against powerful storm surges. Rigorous environmental protocols ensure total preservation of coastal sediment transport dynamics. Acoustic emission monitoring algorithms predict structural settlement long before physical stress occurs. BIM digital twin technology coordinates every phase of complex marine construction. State-of-the-art safety refuges guarantee complete protection for maintenance crews on site.
Specialized marine service vessels move personnel and replacement modules swiftly across the wall. BIM digital twin technology coordinates every phase of complex marine construction. Precision chemical dosing systems prevent marine organism buildup inside turbine cooling pipes. Automated robotic cleaning systems clear debris from turbine trash racks without human risk. Section by section caisson alignment milestones marked steady progress toward grid integration. The Mega Tidal Lagoon power plant stands fully operational, generating clean baseload electricity. Harnessing predictable coastal tides transforms national clean energy capabilities permanently.
Engineering teams celebrate the historic success of Britain's first mega tidal lagoon plant.
The British Mega Tidal Lagoon power plant stands as a monumental triumph of modern engineering. Tapping the endless power of ocean tides secures a sustainable energy future for humanity. Future expansion phases will scale tidal lagoon capacity across the entire British coastline. High-density fiber sensor arrays measure localized current turbulence and shear stress. Automated surface mooring buoys secure navigational channels around industrial sectors. Engineered sediment bypass flumes prevent silt buildup inside the enclosed lagoon basin. Autonomous hydrographic survey boats track underwater profile changes with absolute precision. Advanced cathodic protection systems prevent electrochemical corrosion across subsea steel. Secure access control gates manage personnel and equipment entry along coastal causeways. Real-time meteorological monitoring stations provide early warnings for severe coastal gales. Smart grid routing algorithms balance tidal generation peaks with regional consumer demand. Piezoelectric vibration sensors detect early bearing wear before mechanical failure occurs.
Extensive operational data validates long-term economic and environmental sustainability.
Educational visitor centers and coastal trails connect local communities to clean energy innovation. Clean tidal electricity powers homes and businesses across the nation reliably every day.
The British Mega Tidal Lagoon power plant stands as a masterpiece of coastal engineering.
Global engineering collaboration unlocks the immense power hidden inside coastal tides. Harnessing ocean tides creates an everlasting source of clean electricity for future generations.